slides and
Okay, sir.
also we can listen you. Please.
Okay, sir. Thank you, sir. Uh, my name is Iram Naz, and I'm a student of Center of Excellence in Water Resource Engineering. The work I'm here to present entitled as Evaluation of Groundwater Quality by using the analytical hierarchy process based on the Water Quality Index. These are the contents I'm going to present here. Starting with the problem statement, Punjab's population is increasing exponentially between the 1951 to 2017. It increased by the 4 times. The rapid urbanization and industrialization, the unplanned consumption of the groundwater, lifestyle changes, these are the main causes behind the increase in the water demand, as well as they have an impact on the water quality. Around 80% of the water supply demand chain for the industrial sector is balanced through the groundwater extraction. To assess the suitability of the groundwater for human consumption, it is essential to determine and evaluate its quality. The researchers have used different methods to express the water resources quality. The water quality index, commonly used worldwide, is a simple but a powerful tool for determining the water quality of aquatic bodies. These are the objectives of my research work. First of all, to evaluate the surface and groundwater quality status by using the water quality indices and geospatial approaches. And second one is to propose the different strategies. Here is the study area where I utilize the data points of 1094 from the 5 divisions of the Punjab for the physical, chemical, heavy metals, and microbiological parameters. It is the land cover map of my study area. Here is the flow chart, the framework of methodology for the research work, starting with the data collection and moving towards the computing the index by establishing the weights through AHP method, and then the mapping. First of all, it is the simple structure for the water quality index. Water quality index is a dimensionless number that expresses the water quality of a water body in a single form by aggregating the measurements of the different parameters. First of all, starting with the selection of the parameters, the aim to select the parameters is to have the select those parameters which have the highest influence on the water. Second one is the formation of the transformation of sub indices to common scale, since the values have their own different units. Third one is the establishing the weights. Here we utilized HP method. After that, that is the index aggregation. HPs are main hardcore of study. The HP is the decision-making process where it involves the 3 essential processes: the goal, criteria, and the alternatives. The purpose defines the decision problem that is related to the research objective. That can be water quality, water resources management, and the planning. Here is the water quality assessment. The criteria can be 2 or 2 more. Here are the 2 criteria, that is the drinking and irrigation. And the third one is the alternatives or the parameters. Here we're using the physical, chemical, and microbiological parameters. Here is the weights through the analytical hierarchy process. After selecting the parameters, we move towards the transformation of sub-indices. After that, we construct the pairwise comparison that is based on the questionnaire that is distributed among the respondent. That is by utilizing the SETI scale, the 1 to 9 scale. It is a universally acceptable scale for EHP. We First of all, we calculate the weight by measuring the nth root, after that the aging vector, and then summed up. These are the weights I calculated for drinking as well as for calculating the irrigation water quality index. These are the calculations for formulating the water quality index. These are the we classify the all parameters into two classes, that is positive and the negative. Positive one are those which are higher the better, and negative the lower the better or higher the worse. We assign the weight, we construct the pairwise comparison. These are the positive classes of the positive and negative parameters. That is index of aggregation is by using this formula. These are the grouping of the parameters that are used for analysis. Moving towards the geospatial analysis, the geospatial variations of parameters used in this study, we construct the water quality index maps to identify the zones with good or bad quality. Now move towards the results. First of all, here is this special variations of the parameters. As we can see that the hardness, chloride, nitrate, TDS, fluoride, or total chloriforms, these are the major contaminants in the Sargodha. While we are talking about the Rawalpindi, that microbiological contamination, iron, somehow the hardness is the main issue. For the Lahore, in the Lahore study area, we can see that arsenic, microbiological contamination, TDS, E. coli, and these are the major contaminants. Here is the comparison of available data to groundwater with the international standards. And here is the percentage of number of samples exceeding from the standard. As we can see that in the Punjab, in the overall province, the major contaminants are the microbiological contaminant, following by the arsenic, nitrate, and iron somehow. In the Lahore, the major concern is the arsenic or microbiological contamination, following by the Rawalpindi with microbiological contamination, Gujranwala as well, and Sargodha have major issues of TDS, hardness, chloride, iron, microbiological contamination. Here is the relative proportions of different parameters. As we can see in the first class, the turbidity, pH, TDS, the highest one is the pH. In the second one, these are the ions, cations or anions. Here is the highest one is the total hardness or calcium, following by the microbiological contamination, in which the E. coli is the major contaminant, following by the heavy metal group, in which the arsenic is the major contaminant. Here is the water quality index dimensions for the division. As we can see that the heavy metal is the major problem in the Lahore, and when we are talking about the heavy microbiological contamination, that is for same for the all divisions. Here is the status of different water quality index dimensions for at a district level. Following by the water quality index for irrigation, as we can see that water quality index was used to merge all the previously discussed parameters at one place. We show the overall quality of vector. It is characterized into the four classes: the excellent, good, permissible, and unsuitable. Here we can see that Rawalpindi division and overall a major part of our study area falls into the permissible limit rather than the good or the excellent. However, the Gujranwala and some parts of the Toba Teksing, they fall in a good category. Moving towards the moving towards our next water quality index for drinking. Here we classify them into 5 classes. These are the table shows the index value for the different divisions as well as the area covered by the different classes. Here we can see that the major part of our study area falls into the 120 to 150 premise limit. It means that this area needs some kind of the immediate action plan to restore or to mitigate the groundwater quality that is contaminated by previously discussed contaminants. Here is the mitigation strategies. We devise the strategies based on 2 criteria. First of all, by treating the water to reduce the contamination of the chemical below WHO standards or the standards that are assigned by the international. Second one is by avoiding the chemical contamination, adopting the control measures. The best part is to control the pollution at the source. Here is the formulation of the scenario for treating the water quality, and their percentages we discussed here. First of all, first scenario is for the primary treatment. As we can see that after treating the wastewater with the after passing through the wastewater through the primary treatment, the divisions show a slight change or slight impact on their index value. Moving towards the secondary, we can see the variations from the scenario 1 to scenario 2. Scenario 1 is for the treatment as we discussed previously. We can see the impact of the secondary treatment on index value. The third one is for tertiary treatment. Following by the second strategy, by reducing the or by controlling the source or the pollutant source. First of all, we are discussing this scenario with the microbiological parameters. By adopting these strategies, we can reduce the microbes at source, or we can mitigate the groundwater. Here, first scenario is with the 10% microbiological contaminant reduction, following by the 20% and then the 30%. Same is for the variations in the heavy metal, as the heavy metal is the main emerging issue in all over the province. By adopting these strategies, we can reduce the contaminants, or we can control the source of the heavy metals, that is mainly due to the discharge of untreated industrial effluents. Following by the variations in the chemical parameters, by adopting these strategies, we can control the major contaminants such as nitrate, the calcium, and the TDS in the groundwater. These are the conclusion of my research work. First of all, the microbiological contaminants was found as the major contributor in the groundwater pollution, with 27% and 19% in collected samples exceeding the threshold limits for total coliforms and E. coli, respectively, followed by the arsenic, 9%, iron 7, and the nitrate 6. The water quality index value showed that the 38 of the study area is unfit for the drinking purpose, whereas only 11% falls within the good category. The calculated values for drinking water quality index was found unsafe in the Sargodha, Sheikhupura, Faisalabad, Chennai, Rawalpindi as compared to the WHO standard. The major pollution sources in the Sargodha division were high levels of TDS, hardness, nitrate, chloride, whereas arsenic, TDS, nitrate are dominant problems in the Lahore division, along with the microbiological contamination is a primary challenge in all the divisions. The index value observed with the land use land cover map are highly linked to the depletion in groundwater quality across the study area in the urbanized area. It was found that the primary treatment before disposal of wastewater could improve the 9% area, followed by secondary 35 and tertiary 41%. These are the recommendations. The map produced in the study area can be integrated into environmental and groundwater protection action plan, where the field usage decision of the study area are taken. The next is government should strengthen the present strategies to eradicate the heavy metal and microbiological pollution and ensure the provision of safe water. The third one is future research may be conducted to assess and identify the pollutant sources for the sustainability of the groundwater. Here are the references of my research work. Thank you.
Thank you very much, Iram Naz, for your valuable information about the groundwater quality. And now